Alrighty, this will be lecture 3.8, 3.9, and 3.10. And so that's an unusual situation for us. We're going to have 3 assignments off of 1 lecture. And then the following day after these 3 assignments, we'll have a test, after which we'll have spring break. So we're going to do a little review over stuff we've already covered. The student will determine the quadrant in which the terminal side of an angle lies. So we'll be looking for quadrants. We'll find the reference angle of a given angle. That's the angle formed by the terminal side and the nearest x-axis. And find the coterminal angle for any given angle. And there will be limits to that coterminal angle. So here we go. Let's take a look at what we're doing here. A little walk down memory lane. State the quadrant in which the terminal side of each angle lies. Okay, so let's take a look at it. We've got a situation where we're given an angle in standard position. The initial side will be the positive x-axis. We're going to rotate in a negative direction, 445 degrees. Okay? So here's the direction. This is the indicator of the direction we're rotating. There's 90, 180, 270, 360, 450. I went too far, didn't I? So we're only supposed to go to 445 degrees, and to go all the way to here is 450, so it'd be somewhere right in here, which would put us in quadrant 3. That's a quadrant 3 angle, unless I've made a mistake. Remember, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. I said quadrant 3, I'm in quadrant 4. What's wrong with me? This is a quadrant 4 angle. It's early in the morning. I can't count. There we go. Quadrant 4. Let me see if I got that right, since I started off by making a mistake. Quadrant 4, yay! So there's what we're looking for. Let's take a look at this one, 460 degrees. We have an XY coordinate plane. Our initial side is the positive x-axis. We're going to rotate in a positive direction, which is counterclockwise, 460 degrees. So here's 360 rotation. And then this would be 450, add another 90. 460 would be somewhere over here in quadrant 2, if I haven't made another mistake. So that would be a quadrant 2 angle. This is quadrant 1 right here, quadrant 2, quadrant 3, and quadrant 4. So that's what we're looking for. Let's see if I got that one right. Quadrant 2, yay! Okay, just a little walk down memory lane, stating the quadrant in which the terminal side of an angle lies. Here we're going to be looking for reference angles, and of course we've done this several times. What we're looking for when we're looking for a reference angle is the angle that is formed by the terminal side of the angle and the nearest x-axis. So I'm looking for the measure of this angle right here. So what I'm going to do is mark this off 695 degrees and figure out how much further I have to go, and that'll be my reference angle. Here's 360 all the way to 695. Well, if I went around twice, that would be 360 twice is 720. If this is 695, I'd have to go another 25 degrees. So this would be, in order to get 2 full rotations, 725 degrees, I stopped at 695. That leaves me with 25 more to go to get to 720. So my reference angle is 25 degrees. Right down here. There we go. Okay. Well, let's see if I got that one right. Yay! 25 degrees. I just counted it off and said, well, this 2 full rotations would be 720 degrees. I'm 695 is 25 degrees short of 2 full rotations. All right, let's take a look at this one. I'm looking for the reference angle. That's the angle formed by the initial side and the nearest x-axis. So here's our angle we're talking about, and here's the reference angle we're looking for. The nearest side and the terminal side and the nearest x-axis. So here's negative 360, negative 450, 540, 630. This would have to be another 30 degrees right here. This angle is 30 degrees. It's not the one we're looking for. If this is 660 in a negative direction, this would have to be 30. And if this is 30, my angle formed by the terminal side and the nearest x-axis, the reference angle, would have to be 60 degrees. So in this case, my reference angle is 60 degrees. The angle formed by the terminal side of your angle of rotation and the nearest x-axis. Okay? And let's see if I got that one right. 60, yay! So far we have determined the quadrant in which an angle lies, angle of rotation. We found the reference angle of rotation, that's formed by the terminal side and the nearest x-axis. And the last thing we were going to do was to find a coterminal angle, and I said there would be limits put on it. So we're looking for angles between 0 degrees and 360 degrees. In other words, we're going to limit ourselves to 1 rotation for our coterminal angle. There are an infinite number of coterminal angles for any given angle. We want one that's limited to between 0 and 360 degrees. So here we go. Let's take a look at what 544 looks like. If we were to rotate 544 degrees, our initial side is the positive x-axis. We're going to rotate positive 544 degrees, so here's 360. Here's 540, right? Wait a minute, 360, 450. Here's 540. And then I'd go another 4 degrees if I'm thinking correctly. We do that again, 360, 450, 544. So this would be a 4-degree angle right here. This little angle formed right there. And if I'm looking for a terminal angle, I'm sorry, not a terminal, but a coterminal angle, I'm looking for an angle that has the same initial side, but it's just going to rotate to here and stop. So that would rotate 180 plus 4. So my coterminal angle would be 184 degrees. That's limited to between 0 and 360 degrees. That's the limits we placed on it. And it stops in the exact same place as 544 degrees if I haven't made a mistake. Let's see if I got that right. Yay, 184. So there's coterminal. We've done this before. And just a little walk down memory lane. And we got negative 338. We want to find a coterminal angle between 0 and 360 degrees. An angle that stops in the same place as this one. So let's see where this one stops. Excuse me. There's our y-axis, our x-axis, origin. And we're going to rotate negative 338 degrees. There's our initial side. We're rotating in a negative direction. And we're going to go 338 degrees. Well, here's 270, 338, be somewhere right around there. That's kind of rough. A full rotation would be negative 360. So we are, what is that, 22 degrees from full rotation? So if this is negative 338, this angle right here would have to be 22 degrees to make it a full rotation of 360 if I'm doing my arithmetic right. And so our coterminal angle, that would be this angle right here, has the initial side the same as the positive x-axis. And it just rotates here and stops because it's got to be between 0 and 360 Can't be like negative 338, just less than one rotation. Would just be 22 degrees. My coterminal angle would be 22 degrees if I've done my arithmetic correctly. So this is what we're looking for. There's our coterminal angle. Stops in the exact same place. My drawing isn't very good. There we go, that's a little better. Stops in the exact same place, but it's between 0 and 360 degrees. Let's see if I got it right. 22, yay! So there we are, that's what we're doing today. We were asked to determine the quadrant in which the terminal side of an angle lies, find the reference angle of a given angle, and find the coterminal angle for a given angle. And that's what we did. I started out missing which quadrant I was in. Reference angles and coterminal angles limited to one rotation. You can do this.